Today we're going to do a demonstration comparing our Huskey Specialty Lubricants to the competition. Let's go ahead and start with a high-temp demonstration. What I have here is just a little toaster oven. I'm going to take some of this red bentone grease here. Now, red bentone is a popular grease used in industry. People like it because it has a bright red color and it's kind of thick and tacky, and because of the no-melt bentone thickener, they think this is a good grease for high temperature applications. I'm going to just apply a thin film of this lubricant to this metal plate to mimic actual lubricating conditions. All you really need is a thin film. You don't need big globs of grease to go on there. And I'll just make sure I coat half of this entirely. Now, I'm going to compare this red bentone grease to our Huskey Dynamite Red. Like the red bentone, our Huskey Dynamite Red has a no-melt thickener, but where it's different is it has a semi-synthetic base oil, which is going to make it stand up better to high temperatures. For those of you who like thick, red, tacky greases, go ahead and get a look at that. Now I'm going to apply the Dynamite Red next to the red bentone on the same metal plate. And just look how much better already this product is coating the metal plate. It has better metal adherence, better tackiness. And again, we're just applying a thin film. So let's put this metal plate into this toaster oven for 5 minutes and see what happens when the grease gets exposed to those high temperatures. While we wait for that to cook, let's come down here and do an EP demonstration. This is our Huskey lubricity tester. We have a bearing that rides on a race that gets turned by this electric motor. We have an armature here where we can apply heavy plates to it to mimic extreme pressure conditions. The product I'm going to test today is a moly bentone grease. So just like the last red bentone, although this bentone is formulated with moly, and you think of moly, you think of a product that's going to be able to withstand high pressures, but we'll see if it can pass the challenge of our lubricity tester. I'm going to compare that to our Huskey Tough Stuff grease, which doesn't contain moly, but it has pretty good EP performances, and we'll see which performs better. So I'm going to start the lubricity tester. And apply a generous amount of the bentone grease with moly to the race of the bearing. Now I'm ready to start putting some of the weights on the armature. Now when the lubricant fails, what you're going to hear is a lot of high-pitched squealing. That's going to mean the lubricating film's been broken and we have metal-to-metal contact. So let's start applying weights one at a time and we'll see how many the moly grease with bentone can withstand. There's one weight. It's already getting louder. A second weight is getting even louder. Here comes the squealing. And again, what that means is the lubricant film's been broken. It's actually breaking through the moly, and we have metal-to-metal contact. Now look what happens when we apply just a small amount of our Huskey Tough Stuff grease. Instantaneously, you can hear that high-pitched squealing is stopped. And again, even though our Tough Stuff doesn't contain moly, you can see it's doing a better job providing EP protection. Now, I'm going to go ahead and actually start adding some more weights to the armature there to see how much the Huskey Tough Stuff can withstand. And I'm pretty confident in this grease. I'm actually going to go ahead and do 2 plates at once. That makes a total of 5. Our bentone failed at 3, remember. 7, 9, 15, or I'm sorry, 11, 13, 15. So again, our Bentone grease with moly failed after just 3 plates. Our Husky Tough Stuff grease is going strong with 15. If we had more room on the armature, I'm sure we could even add more. Next, I'm going to do a demonstration on the high temperature capabilities of our Husky anti-seize. Before we actually do that demonstration, let's talk a little bit about packaging. Here's the brush top jars we use for all our anti-seizes. I've cut it open so that you can see inside. You can see that there's a bent metal brush and it goes all the way to the bottom of the jar, and the reason for that is so you can get every last little bit of product out. If we compare that to the competition, you'll see they have just a straight brush and it doesn't even reach the bottom. So think about how much product is going to get lost in the inside of that jar. What a waste. Now, one of the benefits of our anti-seize compared to the competition is that we use a synthetic non-melt thickener. Anti-seizes are inherently designed to work in high temperature applications. And what happens if you don't use that non-melt thickener, the grease will just run off the parts it's supposed to be lubricated. Let's do a little demonstration on that. Here I have a competitor's anti-seize. This is a copper-based, and this is a leading brand of anti-seize. If I told you the manufacturer's name, I'm sure you would recognize it. They promote that this product is good up to 1800 degrees. And we're going to put that alongside our Husky 2000, which is a special blend of copper, aluminum, and graphite. And it will actually withstand temperatures up to 2000 degrees. So I'm going to apply that on the plate next to that copper anti-seize. And if I take this propane torch and just heat the back of this metal plate, let's see what happens when these products get exposed to the high temperatures. I'm trying to apply an even amount of heat back and forth here. And look at our competitor's product. It's just running down the plate. And you can imagine in an actual real-life conditions, what good is that product going to do you if it melts off the parts it's supposed to be lubricating? Our Husky 2000 anti-seize, though, you can see has stayed in place and will provide you maximum lubricating protection up to 2000 degrees. So now let's go back to our high temp demonstration with our Husky Dynamite Red and the Moly Bentone. The timer hasn't elapsed. Oh, there it goes right now. Let's pull these out and see our results. It's kind of smoky. Take a look at that. This is the red Bentone grease, and this is our Husky Dynamite Red. You can see that the red Bentone has turned brown. It's not red any longer, is it? The reason for that is the base oil reached its flash point and it started to carbonize. Whereas with our Dynamite Red, it has a high temperature semi-synthetic base oil, and it's just as red, as tacky as it was before we put it in there. And you can see that it clearly withstands high temperatures better. I hope you enjoyed our demonstrations. I think it's clear to see that our Husky products can outperform the competition across a wide variety of variables. So when you think of high quality specialty lubricants, think of Huskey Specialty Lubricants.